Hey guys, welcome back to part two of this three-part YouTube tutorial series where we go over creating this cool visual effect. In today's video, we're going to build upon what we worked on the last video where we created attributes, and we're going to start prepping our geometry for our RBD simulation. So let's get into it. So we're back here in the Houdini scene we were in last time, and we're going to drop in a geometry node. So we're going to start with a blank slate. And we're going to drop down a tube. I'm going to, first of all, hide all of my previous information. Let's add some resolution here. Let's say 25, and let's add a good amount of columns as well. Then we're going to do our end caps. Then we're going to add in a taper. So one thing that I want to do, first of all, is make sure that the bottom of my tube is at my world origin. One thing that I can do is I can copy my parameter, paste relative reference, and divide this by 2. So now, whenever I do this, my tube will always be in my world center. Then, to make this a little bit more procedural, I'm going to set my height back down to 1, and I'm going to go ahead and copy this parameter and paste it under my capture length. So I'm just going to go ahead and paste relative reference. So now, whatever my height is going to be the same as my capture length. Now, obviously, my capture length is going in the wrong direction, so let's go ahead and change that really quick. There we go. But now, as you can see here, it's the same height. So let's say I've already changed this to 2. My capture region procedurally regenerates. So we're going to use this back down to 1. And let's bring in our taper. Let's do 4. Then we're going to drop in a delete node. And I want to delete based on my normals because I want to get rid of this top right here. Click enable, 1 on the y-axis, 0, and start playing with this. And I deleted my top. Now I don't want this whole space to be filled with points. I want to optimize this a little bit more. So what I can do is I can drop a bound. So that way a bound creates a cube that encompasses the regions of my tapered tube. And I'm just going to go ahead and look at what I'm doing for a second by templating my delete and looking at my bound. Since I've already played with this previously, I've already set up a pretty decent number. So we're going to put this to negative 0.5. And then we're going to create a Boolean. Okay. And now I have the region that I want to focus on. Let's go ahead and untemplate this. So this piece of geometry here is what's going to be the basis for the marbles or the little gumballs that are going to be underneath my active RBD layer. We do this so we can make our scene feel a little bit more full. So we're going to drop in a scatter node. We're going to keep this relatively lightweight for now, so we can keep this at 15. Let's do 15,000. Then we're going to drop in a point jitter after this. Nothing too crazy. We could do something like 0.05. This way we can randomize our position attribute. Then we're going to drop in attribute, adjust the float. And just like how we did in our last video, we're going to randomize the p-scale attribute of our points. So we're going to go ahead and go into our pattern type. We're going to do random. And I want it to be somewhere between 0.03 and 0.05. And then we're going to drop in an attribute wrangle. So in an attribute wrangle, we can start creating custom attributes. And these custom attributes can drive simulations later on. So let me show you what that looks like in action. We're going to create our own attribute here. And when working with this, you have to specify to Houdini what type of data type do I want my attribute to be. So in this case, I want it to be a float, okay? And I want to name this attribute unique underscore points, okay? And I want my custom attribute to be equal to my at Kitina. So what is that going to do? If I click away, you see that nothing really happens. The reason being is because when we write our expressions like this, Houdini isn't writing an attribute. We need to assign this attribute now. So if I were to do something like f at unique is equal to my unique points, so let's just go ahead and copy this and paste it here with our semicolon at the end. Now we are writing attributes out. So in this case, it's getting my ptnum, which is basically the assigned identity of my point. So in this case, my point 0 has a unique point equal to 0. Same for with 1, 2, and 3. However, I don't want it to be 1, 2, and 3. I want these to have random values. So what I can do here is create a rand and encompass this in between my ptnum and click away. Now I have a random number between 0 and 1 that is assigned to all of my points, and it is unique per point. And the reason I went between 0 and 1 is because in Houdini, whenever you do something that is random, it is actually creating a value between 0 and 1. So in this case, you see 0 0.002, 0 0.417, 0 0.813. Now, let me explain to you why I did that. Because now I want to create a color attribute. And I want each of my points to have a random color, but I want it to pick from a specific color palette. I'm going to go ahead and create a color node. I want this to be random from attribute. And we already have our attribute written out, which is unique. I'm sorry, we were actually supposed to do ramp from attribute, and it's already our unique. And now we can pick here different presets. And you'll see that each one of my points are getting a random color in between this color palette. See? So I can play around with this. I can pick Inferno, I can pick Sand, I can pick Plasma, or you can create your own colors. Let's say we want this to be red, this one to be green, and this to be some other color, let's say purple, and everything is getting adjusted accordingly. So now for the sake of this tutorial, and if you want it to be exactly how it's going to look like at the end, then what we could do is our Twilight. So Twilight is picking this color palette. Now we're going to do a copy to points. And here it's asking for our target points to copy to. In this case, it's our point cloud. So it's going to be this. And then here's asking for our geometry. So we're going to go ahead and drop down a sphere. We're going to change this to polygon. And then we're going to go ahead and drop this into our geometry to copy. And when I click on here, you're going to see that it's instancing all the spheres onto my point cloud. And it is inheriting my P scale, and it is inheriting my color attribute of each point. Smooth shaded. There we go. Perfect. Now, after this, we're going to drop down an assemble node because we're going to bring this into our RBD later on. We're going to give this a name. So we'll give this Gumballs underscore static. And we're going to create packed primitives. After this, we're going to drop in a null. We're going to call this out static gumballs. So these gumballs in particular are not going to be moving. They're really just going to be for taking up space whenever the camera's on top of them. Now, for the sake of this tutorial, I am going to bring these up just a little bit more to about 30,000. Because this is being packed here, this is calculating fairly quickly. So do keep that in mind. I'm going to bring this off to the side, and we're going to work on our active geometry. So we're going to pretty much do the same thing that we did in the sense of creating a bounds. Apologize. We're going to drop in a Boolean. So we're going to do the same thing that we did with the last one. So we're going to go ahead and drop this here. I'm going to put this in here. And in this case, I want to keep the top half. So I'm going to change this from 0 to negative 0.3. I wasn't looking at it. So you have our bounding box here. And then we have our Boolean. So it's getting our original tube. We're creating this bounding box, and we're keeping only the geometry that is within our bounding box. After this, we're going to do a transform. So on this transform, we just want to bring this up because we're going to drop our gumballs onto the static gumballs so that way we can randomize their placements, make it look a little bit more natural. So we're going to go ahead and just bring this up a bit. And then we're going to fill this space up with points. So we're going to do a points from volume. We're going to do our point separation of 0.06. And then we're going to jitter our scale so we can randomize the position of each of my points. After that, we're going to do in point jitter. Same way we did before. Bring this down so we have that 0.02. We're going to do the same thing that we did before. So we can just copy and paste our attribute adjust floats, our attribute wrangle, and our color. So now all of my points have the same P scale and color attribute being applied. We're going to get our copied points in our sphere. Same way. I want it to be this one. Then after that, we're going to do an assemble. And in this assemble node, my piece attribute is going to be gumballs, underscore active. We're going to create packed primitives. And then we're going to add in an attribute wrangle. For this one in particular, we're going to add in a new attribute. And this one is called I at bound underscore overlap is equal to 1. So we just created an attribute, which is an integer, and it is equal to 1, which is also true. And what this attribute does is that when we bring in our simulation into DOPS, it's going to allow one frame of our intersections to solve before it starts solving my RBDs. So that way my geometry isn't exploding all over the place. After this, we're going to drop down a null. And we're going to call this out active gumballs. Now we are almost done setting up our geometry for our RBD sim. Now we're going to create our tube to be a collision. So one handy node that we have is called the collision source. So this collision source basically handles collisions for us in Houdini. So if you see here, it outputs a geometry and it outputs a VDB, which you can bring in to our DOPS later on. So let's say we drop in a null here, and we call this out tube geo all for collision. We're taking a look at the actual geometry that it's outputting. If I were to drop another null after this, and let's say we call this SDF, we're now visualizing the volume that it is outputting. In this case, I want to add a little bit more resolution to my VDB, so we'll just bring this to 0.025. We're going to drop in another assemble node here, and we're going to call this output attribute. We'll call this tube underscore environment, create packed primitives. And in this case, I also want to do a VDB reshape, so I can bring down the size of my VDB. I'm going to turn this into a road, so you can just bring it in a little bit more. It's not on my geometry. And finally, we have everything that we need to go into our DOPS. Actually, we're missing one more crucial part. When looking at the final gumball simulation, you notice that they're all being moved around by this invisible force. So let's go ahead and set that up. What we did was we created a tube, same thing. It's polygon. We're going to set this along our x-axis. We're going to add end caps. Take a look at it here really quick. And then our radius scale, we're going to bring this down to 0.01. Our height to 3. And this is looking pretty good. After that, we're going to do a transform. And we're going to bring this up in space just a tad. If we can just visualize our points here, you can kind of tell where it is that we want our tubes to be. So we can just bring this up just a tad bit higher. So we can have it kind of like scraping along the top of the simulation. Yeah, kind of usually a little bit lower. By the way, to look at our front viewport, we can just press space and then we can put 1, 2, 3, and 3 will be our front viewport. Space 1 is our perspective. Space 2 is our top, and space 3 is our front. So let me bring this down just a little bit more. We're going to put it like right there. Cool. All right, let's stop looking at this. And then we're going to do $F on our rotate. So now that means that the value of this rotate on the y-axis is going to be the equivalent of my frame. So in this case, I'm on frame 193. So my rotate is going to be 193. So now this is moving procedurally. Then we're going to drop down a copy and transform. And I want to create a couple of different tubes. So I want it to be 3 tubes. Now you're noticing that nothing is happening here. They're all being created in the same place. So if I were to do 0.1 here, for example, it's going to create a copy, move it up 0.1, then create another copy. In this case, I put 3, and move that 0.1 up from its previous location. In this case, I don't want to move it up in space. I want it to have it rotated. So we can do, oops, not there. We can do, let's say, for example, 45. So now it's moving my tubes 45 degrees from the previous copy. So one thing that we can do to have them all spread out evenly is we can write down this function. We can copy our number of points. We're going to write 180 divided by our number of copies. Press OK. And now all of our tubes are equally distant from one another. So let's say I have 5, it automatically creates them all at an equal distance from one another. This case, we just want it to be 3, and they're all moving. Perfect. We're going to drop in an assemble node again. Piece attribute. We'll call this collision underscore tubes. Create packed primitives. Null. And then this is going to be our aus, all tubes, and so finally we have everything that we need to go into DOPs. We're going to drop down a DOP network. Call this RBD Sim. And we're going to dive inside. And we're going to start bringing everything in. To bring in our geometry that we set up in SOPs, we need to drop down in RBD pack objects. So we're going to start bringing them all in one by one. In this case, this is going to be our active gumball. So we can call this import active gumball. Then we're going to copy and paste. This was going to be our static gumballs. So we name this to the static. Once again, copy and paste. We're going to bring in our geo. So this is our tube that we created. And call this environment. Oh, import environment. Collision. Control C, Control V. And then this is going to be our animated tubes. And it is right here. Cool. Now we're going to go ahead and merge these all together. And now that we have all of our geometry in here, you see everything is in here. Now we're going to do an RBD. I'm sorry, it's actually called bullet server. Okay. And we have 2 options. We can either wire this into here and it'll work just fine, but we're not going to do that. Instead, what we're going to do is drop down a multi-solvent. Drop this in here. Drop this into there. We're going to have our gravity. And then wire this into our output, all here at the very end. And once you have everything going, let's go ahead and just not look at our environment here really quick. I'm sorry, I actually made a mistake here. Once I drop these gumballs onto my collision geo, they're just going to land here on the top. We actually have to do one more thing in order to make this work. So back up here to our collision source. Let's go ahead and use the delete that we used before. Or matter of fact, what we can do actually is wire this into here. drop down a poly extrude. Nope, not that one. Poly extrude. And then we're going to bring this out a little. Let's give ourselves some thickness. Let's say 0.16. So that way our collisions have some thickness to it. Then we're going to output back. So that way we have both sides of our geometry. And then we have our collision source. Perfect, see? That was very important. We needed that for our collisions. So let's go back in here. Perfect. Now we got something working. Before we actually cook our simulation, we need to do a couple more things. So for now, because this is just a trial run, let's go ahead and increase our point separation to something like 1, or rather 0.1. Yeah, so that way we can at least have something to play with. Let's go into here, and then under our environment, I don't want this to move per se. I just want this to be something that it collides and interacts with my actual gumballs. So I can just go in here and do create static object, so that way it doesn't go anywhere in my space. We can do the same thing with our static gumballs. So static object. And one other thing that we need to do here so that it respects our animation is that we have to click on here, create deforming static object. So deforming means that this piece of geometry is moving and it is changing at a per frame basis. Also, I don't want this to be falling in space. I want this to stay here and collide with my actual active geometry. One more thing that we need to do here is use object transform. And let's see what this looks like for now. Oh, so they're all falling on top. Why is that? Has to do with our environment. So if we were to go and find our culprits, if I show guide geometry, yeah, here it is. It's calculating my environment as this sort of object, but we want it to be concave. Let's bring this back. So that way it knows that there is some sort of opening here in the center. So let's go ahead and run that back. Yeah, there you go. See? Now they're all falling in and they are colliding with my tubes. Perfect. Let's optimize this a little bit more. So for one, let's change the collision of our gumballs to spheres. And we're going to do the same thing with our active gumball. We change these to spheres. In doing so, we are basically telling Houdini to save its, I guess you could say, energy in trying to create a collision geometry for these RBD assets that we're bringing in. And instead, we're just creating spheres or tubes, and it makes our scene run a little bit quicker. We're going to do the same thing with our tubes here. There's actually an option called cylinder, so this should help it run a little bit quicker. Let me go ahead and also just change these a little bit up. Once again, I've already played around with these parameters, so I'm going to set this up to be what it was in the original scene. Let me just do that really quick. In our animated tubes, we're going to go to physical, change this friction to 0.1. Perfect. And then under our bullet solver, we're going to change our timescale to 1:1, make this move a little bit quicker. You're probably asking, why is it that we did a multi-solver instead of wiring this directly into our bullet solver? In theory, yes, this would have worked if we just wired them in here. But let's say, for example, we wanted external forces to affect our RBD simulation. So what we could have done is, let's say, for example, we want a pop drag. We can't just wire in a pop drag into our RBD bullet solver. But if we were to drop a multi-solver and drop it into our multi-solver, it would then start affecting our simulation. In this case, we don't really need a pop drag, but that is the reason why we did this method. So let's take a look at what this looks like now. If you notice, our simulation is actually running a lot quicker with our optimization techniques. Are they moving with my tubes? They are moving with my tubes. Cool. So now let's up the resolution on this a little bit more and set this to our cache. So we're going to set this back to what we had it before, which was 0.06. Cool. Bring this back in. And then now we're going to start bringing in our simulation out of our DOP network. But not to do that, we're going to drop down a DOP import node. And from our DOP import, it's going to ask our DOP network. We're going to click and drag here. Then it's also asking for what are we bringing in from our DOP network. In this case, I'm only really interested in my active gumballs. So we're going to click on here, active gumballs. And we're going to go in from import style to create points to represent our objects. So in this case, it's just going to create a point that represents the movements and rotation of each of my assets. Then I'm going to drop down a file cache. In this file cache, I don't like the way that it does things constructed, so we'll just do explicit. And then we could change this to whatever file type we choose. In this case, it's going to go to our $hip. In this case, it's our file directory from where this file is located. It's going to create a folder called geo. And within this geo is going to do a hip name. Hip name is the name of my actual Houdini scene. $OS, which is the name of this cache, $frame in the .bgeo.sc. In this case, I don't necessarily like this style, so we're going to need to copy and paste this and have it create a cache that exists within my geo and is the name of my cache. So in this case, we could call this cache Gumballs RBD version what? Oops, not 991, version 1. And then we could set this to be our render from 1 to 240. We could set this to the 168. Also, if you want to delete what it has here, you could do a delete channel. Or if you go to the delete channel and see right next to it, you could do Control Shift left mouse button. So Control Shift left mouse button, and then it can go ahead and delete that animation or feature. And we could bring this down to, let's say, 168. And then we could do our cache. And then we can go ahead and press save to disk, and it start creating a file cache for our scene. So once this is done, we'll be back and we'll finish up. All right. And it's done with the cache. So what does that look like? Let's see. It's already loading from disk. If I were to press play. Cool. It dropped all my points into my scene. It's okay that these are coming down. Oh, let me change this to 168. Okay. So now this isn't necessarily useful because these are just points, but all of these points are holding attributes that we can use later on. So for example, it's holding in my orient attribute, it's holding in my position, it's holding in everything that we need to bring back our spheres onto these points and set up our final render. So how can we do that? Well, we need to first bring in our spheres. So we do an object merge. And in this case, we can do in Gumball's active. And where is it? It's this one. Oops. Control C. Bring this into our object one. Control V. Perfect. And then we're going to do an unpack after this. And then we're going to do a transform pieces. So now what it's going to do is it's going to take the geometry that I have and use these points to transform my geometry. So I'm going to wire this into my geometry. And here it's asking for my template points. I bring this into here. And once I press play, you'll see that now my spheres are moving along with my points. So now one final thing that we need to do here is if you notice in the final render, some gumballs had this emissive material to it, whereas others didn't. And to do that, we have to set that up here in our SOP network. So we can create an attribute wrangle because we're going to create an attribute that's going to be read in later on in LOPs. and we're going to copy the same attribute that we created before. We'll just copy it here and paste it there. But if you notice, we're not dealing with points anymore. We're actually dealing with primitives now. Okay. So instead of ptnum, we're going to do primno. Oops, I'm not yelling it. I'm saying it. Primno. And I want this to run over my primitives, not my points. So we'll click on here. We'll click primitives. Now, from here, I want this to be an integer, not a float. The reason I want it to be an integer is because I want my gumballs to be either emissive or not a little emissive or kind of emissive. I want it to be either or. So to do that, we have to create an integer. So instead of creating a float, we do integer. And whenever we do random, since it creates something random between 0 and 1, we need to do a function called rint, or round to integer. And we're going to encompass this all within our function. So now it is rounding the decimal to the nearest integer. And then we're going to change the name of our attribute. So I for integer, and we'll call this emissive. Copy this. And just for the sake of being neat, I'm going to paste it here, and I paste it here. So now if you go to our primitives here, you'll see that under our emissive tab, we have some that are emissive and others that are not. So it's between 0 and 1. 0 is not emissive, 1 is emissive. And finally, we're going to drop down a null, and we're going to call this out to walks. Perfect. And just like that, we have prepared our geometry for RBD simulation and did our RBD simulation. Now, finally, in the next video, we're going to bring this in from SOPs to LOPs in Solaris. We're going to render this, we're going to composite it, and we're going to make it look nice. So that video should be coming out soon, I promise. I know this video was kind of long, but thank you for sticking to it to the end. I really appreciate you guys, and make sure to hit the like button, subscribe, comment what you want to see next video or the time after that. And I'll see you guys in the next video. Peace.